Okay, here we go. I'm just going to show you how to do the lab calculations after you've measured your circumference and your height. Now it's time to do some math. So I would open up the PDF with Kami. I don't know if you guys have used it, but it lets you mark up the PDF like with highlighting and text and stuff. Or maybe you've copied it down in your notebook, and that's also totally fine. So I'm on, so we're down past page 1 because we've already done that. And we're on page 2, which is next, use the following diagram and equations to calculate the height of the tree, noting that theta 1 is the angle to the top of the tree and theta 2 is the angle to the base of the tree. The tangent of the angle is expressed as tan. The distance between you and the tree is expressed as AB. Okay, so we're doing some geometry, and I think it's really cool. And if you don't know about Pythagoras and the basically like the whole cult of the Pythagoreans, it's worth a Google. It's super interesting. But anyway, we can use math to kind of discover more about our world, and in this way, we're using math to figure out how tall something is that we can't physically measure. I mean, we could, but it would take either cutting down the tree or climbing it and dropping down like a string or a measuring device. So this is a really cool trick that foresters have used for a long time. And actually now there's just some pretty easy laser devices, like take one measurement, take another measurement, and it tells you how tall the tree is. There are shortcuts now, but this is still a really cool process to learn and a little bit of some math application. So tangent, if you've done the trigonometric functions, is you can find the angle. The tangent is an angle. If you take the distance between the adjacent side, which is this A U to B, and the opposite side, which is this D down to B. So this is the angle we're trying to figure out, and this is the opposite edge, and this is the adjacent edge. So tangent is opposite over adjacent. I remember the SOHCAHTOA. And if all of that is like, what is she even talking about? Just ignore that part. And really all you got to do is plug and play. So we actually already know the angle, the theta 1. So we take the tangent of it, which we'll use our scientific calculators to do that. And then we take these two measurements, dB over, actually, well, we don't know dB. That's what we're trying to figure out. But we put the angle of tangent of theta 1 equals dB over AB. We know AB, we don't know dB, and so that is our unknown value. Think about like the x. So dB equals AB times the tangent of theta 1. Whew, okay, I am not a math teacher. Can you tell? So angle of theta 1, we remember from my tree was about 50. Oh, actually, I need to put this. Look, check that out. We're putting the tangent of theta 1. So I'm actually just going to go ahead and use a Google calculator. Tangent of 50. Let's see if it'll do that for me. I think it will. Sweet, let me just double check that on my phone. Okay, so check it out. I actually did it in my phone, and it's the tangent of 50 is 1.19. And I think that's because Google thought I was talking about radians, but I'm not. I'm talking about degrees. I don't even know what a radian is. So if I'm in the scientific calculator in Google, I can reset it here. And actually, I need to take tangent 50. Is there a degrees button? That's the wrong answer. Okay, well, I will show you in my scientific calculator. So on your phone, you type in 50, and then you hit tan, which is right there. Not tan H, just tan. And it's 1.19. So that's what I'm going to write down. If you can figure out how to use the Google one, great. Okay, so back to my lab. So tangent of theta 1 is 1.19. Tangent of theta 2. Type in 10, hit tan equals 0.01. Gonna round to nearest hundredth, eighth. And then do the next part. dB is the unknown equals AB. Oh, sorry. So dB is the first half That's like eye level height of the tree. And then BC is the second half of the tree, and that's eye level to the base of the tree. So I'm going to do both of those and then add them together. Okay, so 9.45 was my AB. That's the distance between me and the tree. And that was in meters, right? So 9.45 meters times 1.19, which is the tangent of theta 1, equals 11.25, again, rounded to the nearest hundredth. And that is my distance here, dB. That's my height of the tree there. And then the next part of the tree, I don't know, is 9.45. Again, my AB, right? AB times tangent of theta 2, which was 0.018, and that equals 0.17. And then I add those two together, so the total height of my tree equals dB, 25, plus BC, which is 0.17, equals my total height, which I should just be able to do in my head, but I'm just going to calculate it, is 11.42 meters. And I'm going to kind of double check that. Okay, so my tree, the tulip poplar, is 11.5 meters tall. And I just looked up the height of a basketball hoop, and to the very top of it is like, well, it's 110 centimeters, but just move the decimal point because it's metric system, and that's about 11 meters. So that makes sense. My tree seems a little bit taller than like a normal basketball hoop would be. So kind of like double check your answer using some common sense. Like, is your tree actually that tall? And then translate it back into feet if you think better in those measurements. Yeah, so I hope that you enjoy calculating the height of your tree. And then we're going to actually get 4 other people's tree measurements. And so we'll have 5 trees to work with for step